everyone.
All right. Thank you, everyone, for joining us. This is our first ever GitLab Red Team AMA. Real quick, we're going to do a quick round of introductions of the Red Team that we have on the call today. And then we're going to jump right into the questions. We don't have a lot of time, so we may not get to all of the questions that are on here, but our intent is to answer them all. So we will answer anything we don't get to verbally or in the stream here. We'll answer in the document, and we're also going to turn the document into a blog post as well. So we'll be able to get information out there. We also have an email alias that if you have a question that you didn't get a chance to ask or you want to follow up on something, redteam@gitlab.com is a good way to reach the entire team. So real quick introductions. My name is Steve Madzik. I'm the manager of the Red Team here at GitLab, and I'll turn it over to my team. I will start with you, Greg, to go ahead and introduce yourselves.
Yeah, sure. Hi, everyone. My name is Greg Johnson. I'm a senior security engineer on the Red Team here at GitLab.
Fred?
Hello, my name is Frederic of Red, same as Greg, engineer in the Red Team, and I'm based in Europe.
And Chris?
Hey everyone, Chris Moberly on the Red Team as well, based in Australia, and I publish code under the pseudonym initstring.
Awesome. Steve, should we hop into the questions?
Yeah, we might as well. Yeah, let's hop right in.
Okay, so I'll voice over number one, which is considering you're a full remote company, persistence on endpoints is still relevant in your activity, or hunting tokens or credentials make more sense. Some cloud services do not require you to reach them with VPN, so SSO tokens or credentials could be enough in some cases to reach sensitive information.
Yeah, that's actually a really good question. So the simple answer there, of course, is both, right? I mean, obviously, both of those things are definitely important to us, but we have focused a lot over the last little while on going after things like credentials and tokens and things of that nature. In fact, I'll let Greg here take over because he worked on releasing a couple of tools that we actually use internally as well to do this.
Yeah, sure. I'll keep it short and sweet, but you know, when we first started, there really wasn't much in the way of tooling for GitLab specifically for hunting those types of credentials that Steve mentioned. So we modified a tool called GitRob. We're lucky enough to have the original creator on our AppSec team now, but at the time it didn't support GitLab, so we wrote some extra bits in there to make it support GitLab, and we wrote some custom tooling that started out pretty simply as just a recon tool, and then we sort of expanded on that to basically do the same thing that tools like GitRob and other tools like it do, find credentials in different parts of the GitLab system.
Chris, did you have something you wanted to add to that?
Yeah, I did. And just to clarify the question a bit for some folks who may not use the these security words very often. When we talk about endpoints, we're specifically talking about laptops and mobile devices. And the point I wanted to add is it's a bit non-technical. So we're an internal Red Team here, and when we're talking about our targets and endpoints being our targets, those targets are owned by all of our fellow team members, our colleagues, and our friends, and these are the people that we work with, day in and day out. So just in terms of being efficient and being able to get the job done, we need to be able to establish and maintain trust with the people who own these targets, who own these endpoints. There are people who we ask questions to every day. I know I often pop into like development Slack rooms, for instance, and ask how something works. And when people see my name and they see me asking a question and they see Red Team next to it, I want them to trust me, and I want them to feel like they can help and and answer my question and, you know, feel safe that they're not putting themselves in danger doing that. I don't want anyone to think that we're out there trying to exploit their laptops, especially at a company like GitLab, where we're fully remote. So those laptops are sitting inside our homes. They're on our home network, and they're sort of a gateway into our personal life, and they're used for personal things. So when we're talking about persistence on endpoints, it's just not something that we want everyone to think that we're going after their endpoints. And this is why we really like to focus on something that we call an assumed breach. So we need to fully understand the threat model of these endpoints. We need to understand the type of data that's accessible on that endpoint. And then essentially what we'll do is we'll assume that an endpoint can be breached, and we'll start with that level of access that we've identified in the threat model. So probably on an endpoint, there's things like session cookies for an HTTP site, and maybe there's private repositories and API keys. So we'll make the assumption that we have that sort of initial access to the data, and we'll do the red team operation from there. There's also sort of another piece to this with persistence, not just needing persistence inside an operation for us to be able to connect back to something and continue going, but to test our detection and response tools for someone who has established persistence on an endpoint. So what we would do in that scenario is we'd sort of set up a dummy device, and we'd install whatever endpoint management tools or you know, endpoint analysis tools that we have out there on our actual laptops. We'd install that on the dummy device, and then maybe do some testing against that as well.
Great, thank you. We'll move on to number 2. The next question is, to evaluate an insider threat, do you consider to run exercises from authorized users? I mean, run an exercise to simulate a legit change in your system, but with some malicious effects. For example, spin up a new web service or whatever with some backdoors in order to be able to keep access. Steve?
Yeah. So and this kind of overlaps a little bit with the answer to the previous question. So we definitely consider that in some of the exercises that we do. So we will do things, you know, like Chris said in his last answer, where we assume the attacker is either someone that already has some sort of access to something, or is an internal you know, employee or insider threat. And again, though, you know, when focusing on things like endpoints, we have our own test ones that we'll build to look identical to what an end user is using, and then test things out that way versus actually trying to exploit some of our you know, coworkers and things of that nature. Fred, you wanted to expand on that one?
Yeah, just a little example. Like for instance, we will really start with a Linux shell from either VM or container, because we would assume, I mean, the user, since it's an authorized user who is trying to breach anything, he would eventually be able to have such a shell, and we would start the operation from there. And then we would see how far we can expand and how we can detect that. But yeah, just wanted to give an example.
Yeah, and just to expand on that a tad bit, but in the interest of time, I won't go too deep. But as Chris mentioned, you know, we spend some time mimicking how an attacker might try to gain persistence on those VMs or containers as well. So so that we know what that traffic looks like, and we know better how to defend it.
Thank you. And I also want to note, I should have said this earlier, if anyone on the call has a question on what we're talking about, you can always unmute and speak, or type in the chat or the doc. So this can be interactive as well. Let's see, number 3 is, when conducting adversarial simulation and/or exploratory pen testing operations, what systems, platforms do you use to store, collaborate on, and manage testing related intelligence? Steve?
Yeah, that's a great question. So, and this is something that at GitLab that we're always trying to improve on and always trying to iterate on. But we obviously use our own product, GitLab, especially when it comes to the planning and tracking of our exercises, as well as for reporting. Then there's also another tool called Vector that we use that we really like, because it has a lot of the TTPs built into it, and will draw us out some really nice, you know, attack trees and help us track exact actions we take, as well as detection options as well. And Chris, I think you wanted to add something to that one as well.
Yeah, I just want to expand on that a little bit. So if you read my answer in the document here, I use an acronym called TTPs, which is Tools, Techniques, and Procedures. So we leverage our own self-hosted GitLab instance. We use GitLab.com for some things as well, but we also do a lot of self-hosted. And one of the things that we do that I really like is to try to make our techniques for a red team operation automated and repeatable. And we do that by building custom attack tooling. Like, let's say I'll just keep it very simple. Let's say we're doing a password brute force tool or something. We could write our own custom password brute force tool. We would store the code inside a GitLab project. And then we would write what's called a GitLab CI job, which is just a little YAML file where you can put some actions to execute different commands or bash scripts or whatever. And then we can use the GitLab UI, either manually or via schedule, to repeat those techniques. So let's say in an operation, we do a brute force attack and it gets in the report and it shows what time we did it and everything. If the blue team makes some modifications to their capabilities and they want to run that technique again, we can go back to that project and we can look at an exact commit of that custom tooling that we wrote and rerun it with the source code exactly was it at that time. When we run it as a GitLab CI job, then we'll get the full console output, which is logged and it has timestamps and everything that we need to go back and review and see what worked and what didn't is sort of right there inside the GitLab project. We can iterate on it. If we make changes to the source code, we can then rerun it, pin to a different version of our source code, and so on. We even have another tool actually that's pretty interesting that uses multiple pieces of the GitLab project. So it uses some off-the-shelf pen test tools combined with some custom bash scripts that we wrote, and it uses GitLab CI to run this tool. And then the output of the tool, fortunately, is HTML. And we use that tool output combined with something called GitLab Pages, which is a way to host static websites, to host the output of that attack tooling. And GitLab Pages has authentication built in, so we can even do role-based access control on the output of this off-the-shelf pen test tool where only GitLab people can access that output, and it has two-factor authentication built in and all that stuff. So that's just sort of one cool way we can use our own in-house product. And then I did just want to echo Steve's comment on using Vector. Vector is awesome. It is such a cool tool. And for us, it's really helped to improve the collaboration between our red team and blue team. The tool itself, it just looks cool. You put in all the techniques that you did and it builds out this graphical attack map and it has a nice timeline. And every single technique, like let's say you ran a privilege escalation script or you abused a pseudo binary or whatever. Every technique you can sort of drill down into, and there's sections inside the tool where the red team can input what they did, and then the blue team can select whether or not they were able to detect and deter this attack, and if so, which tools were able to get them there. After the fact, you get these really cool reports about how effective all your blue team tools are and things that you can show upstream to management. So Vector is a very cool tool. It's unfortunately, it's not open source. It is free. You can find, they do have a GitHub project and you can download some Docker containers. If anyone ever wants to take a look at it or just wants to chat about it, we've used it a lot and we'd be happy to chat about it as well. You can email the red team at gitlab.com and we can talk more about it. Oh, sorry, and one last thing also, using our own in-house tools, GitLab, just for like project management, not source code project management, but like managing the logistics of a project. There's tons of cool features, things like epics and issues and timelines and tracking and all these things. And if you just type into a search engine using GitLab for project management, there's like a 5-minute video and a 45-minute video and a blog and all kinds of cool things that'll help you brainstorm maybe how you could use it as well.
Thank you. All right, and the next question is, how do you promote collaboration between your team and other security application groups within your organization? What sort of collaborative operations does your team work on?
Yeah, that's a good question. So we're a little bit different in this regard when it comes to, what I would call your traditional red team, right? So most red teams, at least traditionally, would excuse me, would be performing exercises and trying different things in a rather stealthy manner without necessarily telling anybody else. We try to do the opposite, right? So we do, when we're planning our operations, we usually pull people in from different teams, especially teams that'll be impacted, and somebody always knows what we're up to, right? So a good example I have here is if we were working on something that potentially could set off fire alarms for our incident responders in our incident response team, typically the manager of that team or somebody on that team knows what we're doing, knows what we're up to, and then when we are, or if we are detected, we then jointly make the call of, okay, well, do we want to say, fine, you've been caught, let's stop work now, or do we want to actually test what the incident response would be and let everyone proceed through like this is a real incident? So it is kind of at a case-by-case basis, but we are definitely very open and collaborative from the beginning all the way up to the end of one of our exercises. Fred, did you want to add to that one?
Yeah, I just wanted to add a little example. Unless it doesn't make sense, we try, as Steve said, to involve people even during the live of the operation. Like for instance, we will set up a chat channel with the red team members, but also we will invite in the channel some team members from the targeted teams, and they can see live what we're doing. Okay, I'm seeing this now. I'm going to try to elevate privileges here and there. And it's actually, they usually take it very well. And sometimes they even give us some cool ideas actually that we didn't think about. And they don't see this as, because they are part of it really, they don't see this as us trying to like point fingers at them, but really collaborating with them to make things better at the end.
And I think to quickly add to that too, there's always going to be a scenario where we don't want to tell anybody, but even in those scenarios, typically my boss and my boss's boss know, you know what I mean, like so somebody, there is always somebody that knows what we're doing. We just may not share it as broadly or as wide across the different security teams or infrastructure teams as normally.
Number 5 is, how do you break the stigma of red teamers are here to attack us within your organization? How do you promote an environment of trust when certain teams may go into operations with the mindset of, these people are going to tell me my baby is ugly?
Yeah, and that one kind of overlaps a little bit with the previous question too, right? And I think something that I know it took me a while in my career in general to learn and to figure out is that when you do have success, right? Because the thing we have to understand is that when the red team is successful, that means that somebody else maybe wasn't, right? Or like you said, we're calling somebody's baby ugly, right? So we are very careful to not have any ego with that, right? We're very careful to present the facts, the data, the message, and make sure that people understand that, look, we're not here to point fingers. We're not here to tell you that you messed up. We're just here to make sure that, we've done our due diligence and that we've raised, the bar from a security perspective, as much as we can. And a lot of that comes with experience, right? I've seen red teams at other organizations and other places where they maybe forget that, and they, get on that call to explain something to another team where they're laughing about a bug or something that they found. And that's usually not a helpful approach, right? The more helpful approach is to try and be as transparent as possible, share as much information as possible, and not have that ego attached to it.
Yeah,
Greg, did you want to add a
exactly.
little bit to that one, or Fred?
Oh, sorry. Yeah, when I joined GitLab, I saw like this transparency value is really nice because every team is kind of used to show what they do and have like feedback from other teams. So they are kind of used of being pointed at mistakes. And also GitLab is promoting like, yeah, you can do mistakes and just learn from them. So there is some kind of culture of like, yeah, nobody tries to hide really anything. And they're all used to have some different inputs from different teams. So we're an additional input somehow. So we don't show them their baby is ugly because maybe already tons of other teams show them their baby is ugly and they're improving already. So yeah, this transparency value is nice. it brings down the ego, and nobody's trying to really hide anything.
Yeah, and just to add a little bit to that is there's obviously a very human aspect to red teaming that you really can't ignore, and a lot of it is about building trust, early in the process, and making sure that you meet that trust in the end. And the points that both Steve and Fred brought up about working with other teams closely is extremely important, because GitLab is a huge ecosystem of different systems and technologies, and no one person can possibly understand all of it. So getting input from other people and say, hey, this is something that I thought about, maybe we could attack this. It gives you an idea that you may not have come up with otherwise.
Thank you. And the next question is, when planning an adversarial simulation operation, do you try to mimic the TTP usage patterns of known actors, or do you tailor TTP usage to your organization?
Yeah, so the simple answer there, the short answer there is it's both, right? So we use MITRE's attack framework where possible, but we also do adjust and create our own, either based on other attacks that we've become aware of and that we're able to study and learn from, and also just things that we come up with on our own. So something we found at the beginning, right, is that while MITRE's attack framework is really good, it definitely has been lacking in the past in some of the cloud technologies and some of the ways that cloud services get attacked. So that's an area that we've had to really create some of our own. And that's the nice part about this vector tool that we use, is that we're able to create them in there and then actually save them and keep them for future use. And again, like Chris said previously, make things repeatable each time. Greg, did you want to add to that one? You're on mute, Greg.
Thank you. Spacebar just stopped working all of a sudden. In the end, we try not to limit our creativity. I think participating at GitLab and being part of the team as a whole, we learn a lot about how the systems work and where the weaknesses might be that a generic framework like MITRE might not cover. So we try not to limit things, but there's an extreme amount of value in the things that we find in MITRE.
Awesome. And then we had a question come in to chat related to this. So are any of those cloud TTPs that aren't tracked, do I read out the abbreviation? I'll let that pass.
Attack, yeah. I can finish it. Yeah, that aren't tracked in MITRE attack published outside of Vector or where the public can access them. So that's actually an excellent question, because that's something, and Chris, I know you're probably smiling to see that question. That's something we've actually talked about doing, and we need to follow through on. Is we have talked about that as we're creating these, to start releasing them ourselves, and essentially just posting them. We have a area called Red Team Tech Notes, where we publish a lot of different things, and that'll be where we're going to end up publishing any TTPs that we come up with that are outside of MITRE's framework.
Yeah, and actually, so just to add to that, and I know we're right at the end here. So MITRE attack is organized by tactics, which is sort of the high level thing, like initial access and persistence, and then below that there's techniques, and techniques are where it gets very specific, like create a system D service or abuse a SUID binary. So we use the tactics everywhere because they're very generic, and we can sort of fit everything we do in pretty much any operation into MITRE's definition of tactics. When it comes to techniques, though, what MITRE prefers is to only include techniques in their framework that are publicly known and have attribution to some known threat group. And for MITRE, I think that makes a lot of sense. But at GitLab, we're in a much more modern environment. We have no physical networks. We have no Active Directory. And it could be years until there's attribution to techniques that we know work because we've done the research and we've tested them. So again, yeah, we've created sort of a lot of our techniques, reached out to MITRE and had the discussion. But again, as we've learned, they're more interested in techniques that already have attribution. So Ours are probably not going to be included until a threat group uses them and gets caught. We do have some of them published publicly. If you look at our Red Team Tech Notes, we did a very, very thorough blog on techniques inside Google Cloud, for example. In terms of having them broken down like in the MITRE format, exactly how you'd see them in attack, we sort of started on those, but because once we learned that MITRE would prefer not to include them until they have attribution, it was just sort of a lot of work that might not go anywhere. But if people are interested in that and they let us know, then yeah, possibly we could work on that as well. We have some things in the pipeline as well, some upcoming blogs that may be a bit more focused on providing things sort of in that attack framework as well.
And I know we're at time, but this is a good question to end on, so we can answer it quick. What are the exceptional or unusual skills you have in your Red Team? How diverse is the skill set across the team?
That's a good one, and I'll be honest, I had to think on that one because I don't know if we have any unusual skills, you know, in the team, but we definitely have a wide range of diversity in the team. I know for me, something I look for, you know, for people when we're growing the team is not necessarily the skills that people already have, but how easily and how quickly they're able to learn new things and how much they enjoy being kind of thrown into that fire, right? So things change so fast, and there's just so many different moving pieces when we look at GitLab's entire ecosystem that we are constantly put into positions where you know, we have to very quickly learn something and then very quickly figure out, okay, how do I attack this, you know, new thing that I just learned about, right? Yeah, Greg, did you want to add to that one?
Yeah, just quickly, you know, I think we each have sort of a different background and a different skill set, and we all tend to complement each other very well. And you know, usually, if I ask a question, I can, or you have a knowledge gap or something like that. If I ask the immediate team, usually I can get a great answer, or at least a thread to pull to find it. So that's pretty amazing for a team as small as ours.
Yeah, I wanted to add a small one. There are actually some skills that are absolutely useless at GitLab that maybe if you come from a traditional office environment, like I knew I was doing a lot of Microsoft Active Directory stuff, and you can forget about that at GitLab. Anything wireless or related to entering into buildings, no need at all. So yeah, just wanted to point out that I don't think we have anything unusual, but there are some skills that are absolutely useless in a full cloud computing environment. Where everybody is home, basically.
And in the answer document, Fred and I are arguing over who's the best at writing the worst code. So
no,
I say I'm the best at writing the lowest quality code, but we'll see. Yeah.
Nice. Well, yeah, thank you everyone for joining. Steve, I think our plan is to follow up with a blog post. Is that correct? To answer
yeah. So we'll put some answers in this document as well, but we're literally going to just do some cutting and pasting and formatting on the document to get it into a blog post as soon as possible, and we'll add our answers to the final set of questions that are in there. And if we ever do this again, I think we now know to schedule maybe a little more time so we can actually get through all the questions.
Absolutely. Thanks so much, everyone, for joining.
Yeah, thank you very much for everyone's time.